Hey everyone, continuing with our common question types, we have the following example. We are given the curve, the equation, but with unknowns. We have y equals to ax squared plus bx plus c over x plus d, where a, b, c, d are real numbers and x obviously cannot be minus d. The curve has asymptotes x equals to 2 and y equals to 3 minus 2x. So from this information, we have x equals to 2 and y equals to 3 minus 2x as our asymptotes. We can actually solve some of the constants already, which is the idea in part I. Alright, so I state the values of a and d and show that b equals to 7. Now, we then use the information that we have, which is we have the vertical asymptote, which means x equals to 2, which means that x cannot be 2. Right? So because x cannot be 2, it means that we cannot divide by 0, right? Because that's the idea of vertical asymptotes. So, which means that x plus d cannot happen at x equals to 2. So, which means d equals to minus 2. Now, state the value of a. Now, what we also have is the the oblique asymptote. And you know that oblique asymptotes would be sort of the form kx plus h plus whatever rational function that you have. Now, in order to get the oblique asymptote, you would need to perform long division. And in this case, it's quite obvious that the first number that you get after your long division would be a, right? Because if you do your long division, ax squared plus bx plus c, this time around we have divided by x minus 2 because we have the value of d. You notice that the first one's going to be ax, right? And ax will correspond with the minus 2. As such, we can easily say that, well, a equals to minus 2. Alright, so that's pretty simple thus far. So we can just continue on because we find that the value is b equals to 7. Right? Alternatively, what you can do is, we know that if we have x minus 2 here, and we know that this, instead of kx plus h, we have actual value. So we have minus 2x plus 3, right? Same as 3 and minus 2x. What we can do is just multiply them together and then give us the x, right? Because whatever constant this is, so let's say we have constant alpha, this alpha will only affect, or change when we add back the constants after multiplying them together. What do I mean? So if I were to multiply this like this, because I want to make them the same fraction, you notice that the value of x, or rather the coefficient of x on the numerator, wouldn't be affected by alpha because alpha would be a constant. Alright, and as such, we can actually immediately tell the value of b. So we just need to expand this. We get minus 2x squared minus 6 plus alpha for x is simply minus 2 times minus 2 is 4. 3 times x is 3x. So 4 plus 3, we have 7x over a x minus 2. So we then have c equals to minus 6 plus alpha. So I'm going to erase that and just leave it as c. So from here, this will be our working, and we can tell that, well, b equals to 7. Alright, so this will be my working for part 12, showing b equals to 7. Alright. Alternatively, you can do your long division. So from here, you then get ax squared minus 2ax. Then you get b plus 2ax plus c. Then you know that the final one will be b plus 2a. Alright, then leaving you with whatever. From then on, you need to kind of equate that to 3, right? Because you know that b plus 2a would be equals to the constant here. So b plus 2a equals to 3. We know that a equals to minus 2. As such, we have b minus plus minus 4 equals to 3. b equals to 7. Alright, so this two different ways to do part I. Alright, now we move on to part 2, where we have finding the coordinates of the value of c and the coordinates of the other stationary points, considering that we already have the idea that, well, the stationary point occurs at x equals to 1. So what we can do here is apply the idea of stationary points, right? So we have a equals to minus 2 and d equals to minus 2 as well. Alright, so we have the stationary point. So first idea would be the derivative, right? dy dx becoming 0. So dy dx equals to 0 at x equals to 1. Alright, so let's find dy dx first, which is quite simple. 2ax, so I'm actually going to substitute everything. So I'm going to get minus 4x plus 7 times your x minus 2, and then minus away whatever we differentiate below, but you differentiate x minus 2 would be 1, then I get minus 2x squared plus 7x plus c. Alright, and then over x plus, or rather x minus 2 whole thing squared. Then this would be equals to 0 at x equals to 1. Now, the faster way to do it is actually not consider the denominator at all, because we know that for you're going to get a fraction for your derivative. For the fraction to be 0, the numerator must be 0. Alright, so you just submit x equals to 1, you get minus 4 plus 7, 1 minus 2 minus 2 plus 7 plus c. Alright, this would be equals to 0. We then have 3 times minus 1, so it will be minus 3 minus 9, or rather 5 plus c equals to 0. We then have c equals to minus 3 minus 5 equals to minus 8. Alright, so that would be the answer for c. Okay, so now we then move on to find the other x coordinates, which means that finding the coordinates of the other stationary point. So we go back to the original equation right here. Alright, so we have the value of c. So now the second part is to find the x coordinate of the other stationary point. So we go back to this. Now we have minus 4x plus 7, x minus 2, minus 2x squared plus 7x minus 8 equals to 0. Alright, now we just expand everything. We have minus 4x squared plus 2x squared. Here you have 7x plus 8x, so we have 15x, then minus 7x. Then from here, minus 14 plus 8, right? Be careful of your sign, equals to 0. We then have minus 2x squared plus 8x minus 6 equals to 0. Simplifying everything, we have x squared minus 4x plus 3. We then have x minus 3, x plus 1. Sorry, x minus 1 equals to 0. We then the other coordinates would be x equals to 3. Alright, so from here to here, I just divided by minus 2, so that in case you guys get confused, and then obviously it's x equals to 3 or x equals to 1. Alright, then next part, sketch the graph and sketch an unsuitable curve. Again, I think you guys can probably guess it. It's just whatever we've learned in the previous videos where we talk about finding intersection. In this case, you just need to sketch another graph and then prove that it shows you 2 roots, means that you just have 2 intersection points. Alright, so there we have it, the finding unknowns in a particular equations with given the asymptotes, given other information like stationary point, or sometimes even actual coordinates to actually solve for your different unknowns.